So here is the video on how to model a system and also analyze the load flow. So this is the 3-bus system where we have a slack bus, PV bus and PQ bus. So how you determine what type of bus is actually from the parameter given. So let's say for this bus, the given parameters is voltage and angle. So the unknown parameter is actually PQ, P and Q. So this is actually known as slack bus. So for bus 2, the given parameter is P and V. So the unknown is angle and Q. So this is known as PV. PV is generation bus. Okay, and the last bus is the parameter given is P and Q. So where the voltage and angle is unknown. So this is known as PQ bus, which is actually a load bus. So you need to model this system in PowerWorld. So first step is you need to create a new case, and then since we have 3 buses, so you need to add bus. Oh, sorry, I pressed the wrong. It should be. Need to close this first. Okay. So click on draw, and then go to network and click on bus. Okay. So since bus 1 is a slack bus, so the given parameter is 1 per unit voltage and angle is 0. So you can put all the information here. So this is the voltage and angle. So just key in 1 and 0 and click. Since this is a slack bus, so you need to click this, enable it, and then just remove everything and click OK. Right. So the second bus is actually a PV bus. So PV bus the rated voltage is 1.05. So you need to put some information here, 1.05, and then just click OK. So the third bus is load bus. So for load bus, just leave it 1 and 0 for the voltage and angle and press OK. Okay. Alright. So for the first bus is slack bus. So this is slack bus. So you need to add generator on the first bus. Just click on that bus. So you can Okay, so just leave it, just put 0 and press OK. Okay, so since you already key in this bus option as a slack bus, so it will actually automatically acknowledge this generator as a slack, the existing grid. Okay, so for the next bus is generator. So this generator supply output power 200 watt. So click on network and look for generator and click on that bus. So you need to key in 200 watt at here, and then set point voltage should be 1.05. Okay, so put that here. Okay, just leave it the rest and click OK. Or you can actually make it down. Okay, so you can change it like this. And the next bus is load bus. So the load bus require 500 watt and 100 mbar. So click on network and look for load and click at the bus. So okay, 500, key in 500 here, and this will be 100. So okay, so just leave it like that. Okay, so you will need the transmission line to connect bus 1 to bus 3, bus 3 to bus 2, and 2 to 1. So go to network and look for transmission line, AC transmission line. So you need to draw from a line from 1 to 3. Okay, so the parameter for, so this is Z, so this value is R, and this value will be X in per unit. So 0.006 to and for X is 0.0632. So draw the other line from bus 1 to bus 2. Click on that bus and okay, enter R is 0.0047. So for X is 0.0474. Okay, So repeat for bus 2 to 3. So this one is 47 and this one will be 0.0474. Okay. Okay, so we need to display the voltage and angle at each bus. So you can click on fill and select bus fill. So select bus voltage in per unit, and then for angle click on this and press OK. Okay, so repeat for the rest bus. So next you need to actually display the PQ flow at the transmission line. So from the sending to receiving. So click on fill and select transmission line fill. So click at that line and display the megawatt flow, and repeat to display the mVar flow as well. So this is for sending part. So you need to display at the receiving part. So now you can actually display the line losses if you want. So just just go to fill and select transmission line fill. So and click on that line and select megawatt losses. Okay, and mVar losses. So you actually can calculate the losses by minus these two values. Okay, so you can actually display the percentage of loading of your transmission line by double click on this, and then click this, always show value in percentage. Okay, then click run. Okay, so you can actually display the rating of your transmission line by double click on this. So make sure that you display this, always show in always show value in percentage, and then you can actually put your rating of the transmission line. Let's say I would like to put 250. So this one 250 as well. And this one 250. Maybe I should change to 300 because this one actually overloaded. So 300 for this one and 300 for this. Okay, so to perform the load flow, you need to click on run mode. So you need to apply the flag start. So reset all to flag start, means that all the magnitude, voltage and angle will be equal to 1 and 0. Okay, so you can display the log message. So clear all the windows and then try to make it smaller. Okay, so you need to perform the iteration. You need to perform the iteration one by one to actually count how many iteration that required for your system before it actually successfully converge. So first thing is actually you need to set the tolerance of your system. So maybe you can put this one as 0.5, let's say, and then maximum number of iteration, make it like 5. So the tolerance is actually set actually to say your system will successfully converge if the mismatch value are less than 0.5. And then if let's say you repeat the iteration for few times, and then after the system will stop. So your system will stop the iteration if the number of iteration exceed the maximum number. So let's say you repeat the iteration for 5 times, so it's still does not converge, your system fail to converge, it will actually stop, because you actually declare the maximum number of iteration is 5. Okay, so normally for Newton-Raphson, the number of iteration is actually typically between 3 to 4. So it's fine if you put 5 number of iteration. And then for this box, you need to create it. So this one is actually allowed you to perform one by one iteration. Okay. So now you can click solve and apply single solution full Newton-Raphson. Okay. So the simulation is actually did not converge yet. So you need to repeat the second iteration. So still not converge. So repeat again. So after third iteration, your system is successfully converged. Okay. So means that the number of iteration is equal to 3. So you can get all the value. You can get all the value, the unknown value that you need to determine. So let's say for bus 1, given parameter is 1, magnitude, voltage and angle. So this is the PQ value, the unknown. And for PV bus, we know that the value for P and V, and the unknown is angle and Q. Okay, so for load, we know that the PQ value, so the unknown is actually voltage, magnitude and the angle. So you can actually get the total losses from here. So this is actually the total losses for line between 1 and 2. So this is the losses for line 1, 2, 3. So you can actually calculate it, the losses by minus these two values. So 240 megawatt minus 236 megawatt. So you will get 4 megawatt losses. Same goes for the M bar. So 29 minus 7, that's weird. It's actually not accurate, so maybe you can increase the number of decimal point. So let's say you make it 2, so it will actually display more accurately. Okay, and then you can actually analyze the PQ flow for this system. So we have load which is actually 500 megawatt and require 500 megawatt and 100 bar. But your generation only produce 200 megawatt and 267 bar. So the rest of the output power that required for this load are actually imported from the existing grid. Since that the generator cannot support the demand required by the load at this area. Okay, so let's say what happened to your system, you can see that the transmission line is actually working almost close to their rated value, almost overload. Okay, so let's say if the demand require extra megawatt, let's say you put 600 megawatt here, so these two lines will be overloaded. Okay, so you can actually increase the load. Let's say you need to increase 20 megawatt once you click mouse at this area. Okay, so when there is actually increasing on your load, okay, so you can remove this. Okay, so click this, it will actually run continuously, so you can keep on increasing your load. Supposedly, when you increase this, if you increase this, actually it should be blackout in your system. Okay, so now actually your system can no longer operate because there's a blackout in your system. Okay, supposedly if your transmission line working at when your transmission line working more than when your transmission line actually operate over their limits. So you you will facing a blackout in your system. Okay. So therefore, it is actually very important for you to perform a power flow studies to analyze what are the whether your system, especially your transmission networks, actually support the increment in your load and generator. So let's say there is a load growth in your demand. So you need to to overcome the overloading in your transmission line. You can actually plan for the new transmission line. Um, which can actually connected in parallel to this to the existing transmission line. So that's it, I think.